One of the drawbacks of an acid-catalyzed hydration reaction is that there's the potential for a carbocation rearrangement. In some cases, we don't want that carbocation rearrangement to occur, so we need a different set of reagents. In this case, we would use an oxymercuration demercuration reaction. This is an electrophilic addition reaction, very similar to the ones that we've seen before, and again, we're going to be adding water across a pi bond. But because of the reagents, we will prevent the formation of a carbocation that can rearrange. The reagents for this are slightly more complicated. We have mercury acetate with water, and then we have a second step after this is allowed to react where we add in sodium borohydride. This will give us the same product as a standard hydration reaction. First, we can treat the mercury acetate as a salt. So one acetate ion comes off, and the mercury ends up with a positive charge. This means it's a good electrophile. So our nucleophilic pi bond can attack the electrophile, generating a carbocation, in this case a secondary carbocation, as you would expect in terms of stability. Now, in a hydration reaction, we would expect that we could have a hydride shift from this carbon atom, which would allow us to form a tertiary carbocation. In this case, this doesn't occur, because the mercury can actually donate electrons to that positive charge and have a resonance form where we have this cyclic species where the positive charge is moved to the mercury atom. Because this resonance form exists, the secondary carbocation that we see here is actually relatively stable, and a hydride shift is not energetically favorable. So we'll be left with just this secondary carbocation. The water molecules from the solution will be able to attack that secondary carbocation, make a new carbon-oxygen bond. Then we have this extra proton on our alcohol and an extra positive charge on the oxygen. The acetate ions in solution will pick up that proton, and we will eliminate the positive charge on the oxygen. Finally, we almost have our final product, except we've got this mercury species. So after this process is complete, we will add in a solution of sodium borohydride, which you can treat as H-, and without talking about the mechanism too much, you can just say that it displaces the mercury with a hydrogen atom. So again, we take our original pi bond here, we've added a hydrogen and an alcohol. To summarize, an oxymercuration demercuration reaction proceeds via an electrophilic addition mechanism. We add an alcohol and a hydrogen across a pi bond. We form the Markovnikov product, just as in a hydrohalogenation reaction. We will also see a racemic mixture, but unlike a hydration reaction, we do not see carbocation rearrangements. They don't occur.